In this video, you will learn about Keras Tuner. Keras Tuner is an optimization framework that solves the hyperparameter search. It helps you find good hyperparameters for your deep learning model. It helps you pick the optimal set of hyperparameters for your TensorFlow program. In this tutorial, you will use the Keras Tuner to perform hypertuning for an image classification problem. First of all, we need to install the Keras Tuner. In Windows, type cmd. Open your command prompt, then type pip install Keras-tuner. Press enter. I got a message that requirement already satisfied, that is, it is already installed in my system. I'll close this window. Let's import TensorFlow STF. Import TensorFlow STF. From TensorFlow, import Keras, and let's import the Keras Tuner. Import Keras Tuner as KT. Let's execute our code. This will import all these three modules. In this tutorial, we will use the Keras Tuner to find the best hyperparameters for a machine learning model that classify images of a clothing from Fashion MNIST dataset. To get more information about the Fashion MNIST dataset, you will come on this GitHub page, and once you come here, you will see the description about the dataset here. So we have 60,000 examples for training, and for test set we have 10,000 examples. Each example is a 28 by 28 grayscale image associated with a label from 10 classes. So these images are of size 28 by 28 and grayscale. These are black and white images, not color. And we have total 10 classes here. So you will see in this image we have different types of cloths, then we have shoes, sandals and trouser, and there are 10 labels. So you will get the information about the labels also. Here are the labels. Each training and test example is assigned to one of the following labels. The labels are t-shirt or top, trouser, pullover, dress, coat, sandal, shirt, sneaker, bag and ankle boot. And all these labels are given number between 0 and 9. So for t-shirt we have the number 0, for bag 8, for ankle boot 9. So this is the data set here, and we are going to load this data set in a Jupyter notebook. Let's go to the notebook. Now I'm going to make some variables to save this data set, and I'm going to make tuples, two tuples. One tuple will contain the training data set and the other tuple will contain the test data set. So I'll make first tuple image underscore train and label underscore train. So this tuple will contain the training information. So we have the images for the train data set and also the label for the train data set. Then I'll make one more tuple, and this will have image underscore test and label underscore test. So this tuple will contain data set for the testing from Keras dot datasets dot fashion MNIST dot load underscore data. Using this function we will load our Fashion MNIST dataset in these two tuples, this image train, label train, image test and label test. Let's execute our code. We have successfully imported the dataset. Let's look at the shape of the training and test dataset. So I will write image underscore train dot shape. In training we have 60,000 samples. We have seen that it was written on the website that there are 60,000 samples for the train set. And now let's look at the test set. Here in test set we will have 10,000 or 10k. I will write image underscore test dot shape. In the output you can see we got 10,000 images in that test set, and these images are black and white or grayscale and their size is 28 by 28. Let's import NumPy to check the minimum and maximum number present in our train and test data. I'll import NumPy as np, and I'll tell you why we need to check the minimum and the maximum number. First let's check it. So I will call numpy np dot minimum. So I'm going to find the minimum of first train images. So I'll just copy this variable from here, I'll paste it here. The minimum is 0. Next I will find the maximum, np dot max, and then I'll paste the argument. Let's execute our code. The maximum is 25. Now we will do the same for the test one. So I'll write np dot minimum image underscore test. In test we have the minimum value as 0. np dot max image underscore test, and in test also we have the maximum number as 25. And why we have checked this because we will bring down the minimum and maximum values between 0 and 1. So the minimum will remain 0 but the maximum will be 1, and convert it into float from integer. We will see here that these are the integer values. We are going to convert it into float also, and we will do this because TensorFlow works better on numbers between 0 and 1 and the data type float. That is why we are going to convert all these numbers between 0 and 1 and convert it to float, because the architecture of TensorFlow has been made like this that it works better on numbers between 0 and 1 and the data type float. Now then once we do that, then we will normalize the data. So I'll call this image underscore train. This is our variable here. You will see in our tuple image train and image test. So first I will call image train, and then I will call image underscore train dot as type. This is to convert our data type into float from integer. So I will type float 32. I'll make it float 32, and then I will divide it by 255.0. So here I am saying that I'm going to convert this data into float 34 and then divide it by the maximum number. The maximum number is 255.0 because I want to convert it to float. So when I divide this number with 255.0, it will become 1. Let's execute our code. I'll do the same for the test also. I'll copy this code from here and paste it here. Now instead of train I will type test, and here also I will change it to test, and rest of the things will remain same. Let's execute our code. So we have converted it into float, and now we can check np dot minimum of image underscore train. You can see we have the minimum number as 0.0. np dot maximum of image underscore train. The maximum number is now 1.0. Earlier it was 255. You can see here. So we have converted it, and we have also bring down it between 0 and 1. Next we will define the model. When we build a model for hypertuning, we also have to define the hyperparameter search page. In addition to the model architecture, the model you set up for hypertuning is called a hypermodel. In this tutorial, we will use the model builder function to define the image classification model. The model builder function will return a compiled model and use hyperparameters that we have defined in line to hypertune the model. Let's make one function, define model underscore builder. This is going to be our model builder, and this will take one parameter HP, that is hyperparameter. Now inside this we will define our model. So we will make one variable model here, and then from Keras we will call the sequential model Keras dot sequential, and then we will add one layer, and to add a layer we have to use the method add. So I will type model dot add. We are going to add the layer flatten, Keras dot layers dot flatten. This will flatten the image, and then we have to pass input shape, input underscore shape, and we have to give the input shape here. So the input shape is going to be 28 by 28 because our image are grayscale and their shape is 28 by 28. So the input shape is going to be 28 by 28. Then I'll make one variable HP underscore units. First I will define this, then I will explain you. Then I will call from this integer hp.int units, and minimum value is going to be 32. Then maximum value, we have to define the minimum maximum value. Maximum value is going to be 512. And then we have step function, step is going to be 32. So this will tune the number of units in the first dense layer. It will choose an optimal value between 32 and 512. So this we are using to tune the number of units in the first dense layer, and it will take the minimum value as 32 and the maximum value as 5112, and the step will be 32. So for example, the first step is 32, then the next will be 32 plus 32 is equal to 64, then the next will be 64 plus 32. So this way it will keep on increasing until it reaches 512. Then we will add one more layer. I will call model.add keras.layers.dense. Then I'll define units, and units, it is going to be HP unit. This variable we will pass HP units, and we also have to define the activation function here. So I will type activation. We are going to use the ReLU activation. ReLU. We will define one more layer. I will type model.add keras.layers.dense. This is going to be dense layer, and this will have the number 10 because there are 10 labels I have shown you. Let's go and check again. So here in the data description I have shown you there are 10 labels. You will see between 0 and 9, and that is what I have defined here as 10. Then I will make one more variable, hyperparameter learning. So this will have learning rate, HP learning rate, HP dot choice, and this choice will help us to pick the learning rate of its choice, and inside this we will pass learning rate, and we will put the values. The values are going to be between 1 e raised to minus 2, 1 e raised to minus 3, 1 e raised to minus 4. So this variable HP learning rate, I'll tell you what it is doing. This will tune the learning rate for the optimizer. So we have this optimizer here, and this will tune the learning rate, and this will choose an optimal value of learning rate between these numbers. So these numbers are, this first one is 0.01, the second one is 0.001, and the third one is 0.0001. So it will choose the learning rate between these three numbers. Now let's compile the model. So we have added the layers. The next is we have to compile the model. I'll type model.compile. Compilation is very important. Then we will define, inside this compilation we will define the optimizer and other parameters. The first parameter is going to be optimizer, and for optimizer we will use keras dot optimizers dot Adam. We will use the Adam optimizer, and inside this we will pass our learning rate. So I will write learning rate is going to be this variable HP learning rate, HP underscore learning rate. Then we will define the next parameter. The next parameter is loss. we have to define the loss function here. So our loss is going to be Keras dot losses dot sparse categorical cross entropy, and inside this I will pass one parameter from logits is equal to true, and the last parameter will be metrics. We also have to choose the metrics to check the performance of our model. So we will type metrics is equal to accuracy. So we have defined this function, and this function will return us model. This function will return us the model. Here you will see this model, this function will return. Let's execute our code. I have to put this inside the function here. Let's execute it again. So we have defined this function model builder. Let's instantiate the tuner and perform hypertuning. The Keras tuner has 4 tuners available. First, random search, second, hyperband, third, Bayesian optimization, and fourth, scikit-learn. In this tutorial, we will use the hyperband tuner. To instantiate the hyperband tuner, we must specify the hypermodel. I'll make one object tuner, and then I will define the tuner here. I will call KT. We imported the Keras tuner as KT. If you remember, here you will say import Keras tuner as KT. So I will write KT dot hyperband, and inside this we will pass our function model builder that we have made above, this model builder function. I'll pass it here, model builder. Then the next parameter is objective. Our objective is to get the validation accuracy, validation VAL accuracy. Next parameter is maximum epochs, max epochs, and we will say 10. We want to run this model 10 times. The maximum number of times we want to run this model is 10. That's why maximum epochs is 10. Then we have factor. We can put any number here. I am putting 3. Then we have to define the directory. This is just the place where you will save. So you can write anything here, my dir. The next parameter is project name, project underscore name, and you can put any name here, my underscore tuner. That's it. Let's execute our code. We got the error here. TensorFlow module TensorFlow.keras.layer has no attribute flatten. Instead of small f, I have to make it capital F. So I'll go here and make changes. I'll make it capital F. Let's run this again, and now let's run this again. So we have run this tuner here. Now now we will create a callback to stop training early after reaching a certain value for the validation loss. So we are going to define one callback function, and as I have told you in my previous tutorial about callback. So callback is to stop the training of the model at the earliest when it reaches a certain amount of loss. So for that we define that. So I'll make one variable stop early. This is going to be our callback from tf.keras.callbacks dot early stopping. Inside this I will pass one parameter monitor is equal to validation loss. We want to monitor the validation loss, so we will check the loss at each and every epoch, and then we will pass on parameter patience is equal to 5. Let's execute our code. So it says that TF is not defined. Here instead of TF I imported TensorFlow as F. I'll make it TF. I'll run this again. And now I'll call this again. So I've defined this early this callback here for the early stopping. Now let's run the hyperparameter search. So I will call this tuner that we have defined above. I'll write tuner dot search. Inside this I will pass our training data, image underscore train, then label underscore train. We will define the epochs. The number of epochs are going to be 50. Then we have validation split. The validation split is going to be 0.2. So 20% of the data will be used for the validation, 80% for the training. Then the next parameter is callbacks. So we have already defined callbacks above. This here, stop early. I'll just pass this stop early as our callback. And this has to be inside the list. So I'll make a list here first. Now it's fine. Let's execute our code. So this is running and this is looking at the best hyperparameter. And you will see here we are getting some error, some messages, not error. It has completed the tuning and we got the best validation accuracy score as 0.89 or 89%. So the best validation accuracy score after this tuner search tuning, we got it as 89%. Now we can look at the best hyperparameters and save it in a new variable. So I'll make one variable best underscore HPS and I will save the best hyperparameters here. So I will call tuner dot get best hyperparameters, and inside this I will pass in parameter number of trials and I'm going to put it as 1. You can put other number as well. Let's execute our code. So we have saved the best hyperparameter in this variable best underscore HPS. Now let's print and check. I'll type print best HPS dot get units. So first we will look at the best units here, get dot units. Let's execute our code. And the best unit is 448. Here you will see above we have defined the number of units and it is between the minimum value is 32 and the maximum value is 512. Here we have defined this units. So the best unit is 448. And now let's find the best learning rate. So let's type print best HPS dot get, and inside this we will write learning rate, and the best learning rate is 0.001. Here in above you will see that in the above example here we have defined the learning rate. These are the 3 learning rates we have defined, and out of this we got the 0.001 as the best learning rate. Now we can use this best hyperparameter such as the number of units as 448 and the learning rate at 0.01, and then we can tune our model. So we will do that. Let's train our model with the optimal hyperparameters and train it on the data. I'll make one variable model and then I will call tuner dot hyperparameter model dot build, and inside this I will pass the variable best hyperparameters. Now I will make one variable history. Now I will call model dot fit on our training data set image underscore train, then label underscore train, epochs is going to be 5. I don't want to keep the model running for a long time, so I'm typing 5 here. Validation split, it is going to be 20%. We are going to take 20% for the validation, so I have provided 0.2. Let's execute our code. Now it will run for the 5 epochs using the best hyperparameters, and the best hyperparameters are units is 448 and the learning rate is 0.08. So earlier we got the validation accuracy as 89%. Let's see what we will get now. So we completed this model training. So here we will see we got 89% because we ran this model 50 times, and here we got 88 because we ran this model for 5 times only. So if we increase the number of epoch from 5 to 50, this will give you a good accuracy. I'm not increasing it here because it will take a lot of time to complete the epoch. So you can try, you can put 50 or 100, whatever you want, depending on the time that you have. So I'll keep it as 5 here, and if you increase the epochs, your accuracy, the validation accuracy, will go up and go high. We can also save this result in a new variable. So I'll write validation accuracy percent dot epoch, and then I will call from history dot history validation accuracy. Let's print validation accuracy. So these are the accuracy we got 85%, 87%, 87%, 87%, and 88%. So the best one is 88%, the highest one. So that's why here you will see we have the last one as 88. So if you look at the first epoch, here you will see 85, and that is what we got here in this list, 85. The next one you will see 87. So here you will see 87. Here also we got 87. Then 8718, 8718, 8777, then 88, 8849. So this is how we got the validation score. You can also save the other parameters if you want. So this tutorial was about Keras Tuner, how you can use this Keras Tuner to search the best hyperparameters for your model. I hope you enjoyed this video. If you like my video, please subscribe to my channel. Thank you for watching.